Hello guys, in this video I present you yet another interesting project, ultra high fidelity head avatars via dynamic Gaussians. High fidelity 3D human head avatar modeling is of great significance in many fields such as virtual reality, augmented reality, telepresence, digital human and film production. Automatically creating high fidelity avatars has been a research hotspot in computer vision for decades. Although some traditional head avatars can realize high fidelity animation, they typically require accurate geometries reconstructed and tracked from dense multi-view videos, thus limiting their application in lightweight settings. The good thing about this project is that not only they have provided the research behind it, but also they have shared the code which you can access it from this GitHub repo, and I will drop the link in video's description. If you go through their project page, they have given some of the examples. Just look at this. There is a reference image and then there are two avatars, and their sync motion is really awesome. Thanks to the neural radiance fields or NERF, which show great capability of novel view synthesis in the absence of accurate geometry, recent methods skip the geometry reconstruction and tracking steps but directly learn high quality NERF based head avatars. A lot of other research has verified that NERF can be applied to either dense or sparse views, which greatly lowers the threshold for head avatar reconstruction. However, it still remains challenging for these NERF based approaches to synthesize high fidelity images at 2K resolutions with pixel level detail including wrinkles and eyes. And that is where this research helps a lot. To overcome this bottleneck, what they have done is they have introduced this 3D Gaussian splatting for 3D head avatar modeling. Then there are a lot of examples which are present. Look at this one, this is even better. And then look at this one. And these are all cross reenactment results. This is an explicit discrete representation that can be well adapted to the rasterization based rendering pipeline. It has been verified that the 3D Gaussian representation is capable of render complex scenes with low computational consumption. Compared to NERF, the reconstruction quality of static and dynamic scenes is much better while rendering time cost has been significantly reduced. And that is where they have proposed this Gaussian head avatar, which is a novel representation that utilizes 3D Gaussian splatting for ultra high fidelity head avatar modeling. Although recent 4D Gaussian works have been proposed to reconstruct dynamic scenes, all of them cannot be animated. For modeling, the animatable head avatar is crucial but still unexplored how to effectively control the deformation of 3D Gaussians and the model the dynamic appearances through expression coefficients. And there are, as I said, there are a lot of other examples in this which you can see. Now, in order to give you an overview of their method, let's look at the architectural diagram. Now, if you look at this diagram, this is the overview of Gaussian head avatar, and this is primarily the rendering and reconstruction. They first optimize a guidance model, including a neutral mesh, a deformation MLP, and a color MLP in the initialization stage. Then they use them to initialize the neutral Gaussians and the dynamic generator. Finally, 2K RGB images are synthesized through differentiable rendering and the super resolution network. The Gaussian head avatar are trained under the supervision of multi-view RGB videos. Also, if you look at some of the implementation detail, they have used 12 sets of data, 10 of which are from Netsample and the other two are multi-view video from the H avatar. For the 10 identities from Netsample, each set contains 2500 to 3000 frames. 16 cameras are distributed about 120 degree in front and simultaneously capture 2K resolution video. For each identity, they have used the sequences marked with free as the evaluation data and the rest as the training data. Now, they have all for the pre-processing, they have already removed the background and have extracted 68 2D facial landmarks for all the images. And probably that is why the quality is so good. And just due to that, this method is capable of creating artificial portrait videos which have the potential to disseminate misinformation, influence public perception, and erode confidence in media sources. This can result in considerable negative impacts on society, so it is very critical to consider approaches that can reliably distinguish between authentic and fake content. Although this method has taken a substantial step forward in the quality of image synthesis, a lot of things needs to be done. For example, there is one problem which still hasn't been solved. For the tongue and teeth inside the mouth or long hair, blurring is sometimes produced in their method due to the lack of tracking method. All in all, a real good impressive research. This Gaussian head avatar, which is a new representation for head avatar reconstruction, which leverages dynamic 3D Gaussian controlled by a fully learned expression deformation. Also, there is a lot of other detail in the paper, and experiments have demonstrated that their method can synthesize ultra high fidelity images while modeling complex and exaggerated expressions, as you can see on your screen. They have also proposed a well designed, minute level initialization strategy to ensure the training convergence of the Gaussian head avatar. And it is believed that their Gaussian head avatar will become the mainstream direction for head avatar reconstruction under sparse view setups in the future. So that's it, guys. I think that pretty impressive research, as you can see on your screen. But still, there should be some guardrails, there should be some regulations because this could very easily be used for any mispurposes. So, because this method has already surpassed recent state of the art methods under lightweight sparse view setups. So, let me know your thoughts in the comment and especially around how to guardrail and secure against the forgery and fake content in this day and age of social media. If you like the content, please consider subscribing to the channel as that helps a lot. And do me a personal favor, if you're already subscribed, then please share the content, share the channel among your network on the social media, in email, wherever you like, as it helps a lot. Thanks for all the support and thanks for watching.